Hi friends, today we are going to think about how to create palindrome from a given string. So our question is, we need to do minimum number of insertion of the characters into a given string such that the new string which will be created, it will be palindrome. So let's consider this kind of examples. Let's say we have a string A. A itself is a palindrome because there is only one character. So that's why the number of characters required to insert into this string is 0. Now say suppose we have AB. That means we can either create ABA as in a string which is palindrome. We are inserting A at the end, or we can create BAB. So we are inserting B to the front and we are creating a palindrome string. In any of the case, the minimum number of string or minimum number of characters which are required to insert are 1, correct? So in this way, and say suppose the third example, say suppose there is an ABC, then again, either we can create ABC, BA in this way, or some other, but minimum number of strings or minimum number of characters which is required are 2. Let's take some other example. We all are geeks, so let's create the string geeks, the palindrome one. So we want to create geeks, the palindrome one. Let's see how many minimum number of characters are required. So over here you can see I can create G, double E, K, S, and I'm inserting G over here. So G and G are creating a palindrome. They are matching. Now I need to insert this K and S such a way that the geeks will be generated into the palindrome string. So I can create something like this: G, S, K. I'm inserting SK over here. E and E are already palindrome because they both are matching. K and S, the reverse of it, and G. So if I'm inserting, you can see that I have inserted only 3 characters, SK over here and G at the end. So that means I have inserted only 3 characters and I have created the geeks into a palindrome string. Now let's think how to create an algorithm and pseudocode out of it. So before creating any of the solution, let's think in this way. Key, we have say suppose given a string str in which there are n characters. Okay, consider it over here. Say suppose A, B, and C, and we will also take some extra characters, something like A, B, C, and A, and then we'll build up our strategy. So let's think in this case, how do we want to proceed and how do we want to create a string, a palindrome string out of the given string. So if you see perfectly, there are 2 cases. In a palindrome, first and last characters are always matching, and then second character and the second last characters are matching. So in order to create a palindrome string out of the given string, what we need to do is we need to find it out whether the first and last characters are matching or not, and furthermore, so we'll check either the first one and the last ones are matching or not. So when we are writing an algorithm, we may need to pass the first and last pointer to it. So that's why we'll write algorithm something like this, in which we'll pass the starting point and the ending point. So we are going to need starting point I'll say as an L, and ending point as an H. So I'll check whether L and H are matching or not. Now say over here L and H are matching. So if L and H are matching, string of L and string of H are matching, we just have to check whether the rest of characters are matching or not. If they are not matching, then minimum number of characters we need to insert into that. And if In this case, L and H are matching. So in rest of the characters, we need to check. And if in this case, A, B, and C, the characters are not matching. When the characters are not matching, in those case, we need to check whether we can create a substring out of it, a palindrome or not. So what it can be the substring? It can be something like this, that I insert over here. That means in between B and C, or I insert at the start. That means over here before A. So there will be several cases that we need to check. So what I'll check is either I'm not considering C, or either I'm not considering A. So either I'm checking something like this, for A and B, can I make the palindrome? Or for B and C, can I make the palindrome? So if B and C are the palindrome, I'll respond it to ABC that yeah, minimum number of characters to be inserted are XYZ, or 1 or 2 or 3, whatever the answer comes. So in this case, in this way, we need to proceed. So we are creating a recursive formula out of it. So recursive formula will be built up something like this, that if string of L equal to string of H, if string of L and string of H both are matching, then say suppose the algorithm name is find minimum insertion or get minimum insertion, to which we are passing string, we are passing integer L as a starting and integer H as an ending point, and there will be some base case condition to terminate our recursion. Now if string of L and string of H are matching, we may need to check get minimum insertion function with the same string, but as we saw in this case, when these both are matching, we just need to check whether the rest of the string is making palindrome or not. If not, then which minimum number of characters we need to insert into that, and that we will return. Correct? So in this case, it will be this. And in else case, it will be something like this, minimum of get minimum insertion of string. In this case, we are just moving forward, and over here we are moving from backward. So string L plus 1 and with the same H, that will be this case B and C, or the minimum from or minimum between get minimum insertion of string L as it is and H minus 1. That will be AB's case. That we need to return. So over here we'll write directly return, and over here as well return. So this thing we will return directly to our recursive function. So let's see what should be our base cases. So let me put this whole code or pseudo code below so that we can understand which kind of base cases we need to cover. So let's think in this way. Over here we have two strings, correct? L and H. Obviously L and H, if L is greater than H, because we want to see starting L and ending H, if they got swapped, then there is no way that this character or this string can be converted into palindrome. So in this case, because we wanted to get the minimum characters insertion, we'll return integer max. So if there is one base condition, if L is greater than H, we need to return some large number or int max. That is fine with us. So in C we are returning, or C++ we are returning int max or some large number in Java. Now as we know that if there is only one character A which is already palindrome, so say suppose in this case if it is ABA, both characters are matching, so we'll go for this one. And in this case L and H are pointing to the same one, L and H are pointing to B. In this case there is only one character, so if it is one character we just need to return 0, because there is no insertion required to create one character as in a palindrome. So that's why we'll write another base condition as something like this. If L equal to H, return 0. Now say suppose in this case AB, there are two characters AB. Now over here, if A and B are there, we'll again proceed something like this, that we are going with A and then we are going with B and then we are returning 0 and 0 over here. If we are returning 0 over here and 0 over here, it will return minimum of 0 equal to minimum of A and B equal to 0, correct? So over here, if we return 0, that means to create AB as in a palindrome, 0 characters are required, but which is not true. So that's why either we need to add +1 or we need to check directly from here. If there are 2 characters, we need to check whether how many characters are needed to insert to make this AB a palindrome. So we know that if there are 2 characters AB, or say suppose AA, or say suppose BB, if there are 2 characters, to make this string as in a palindrome, we need only one insertion, which is like either ABA or BAB, correct? And if they both are matching AA and BB, that means we need to just insert 0 characters. So that's why one condition will be written something like this. If L equal to H minus 1, which is just one step behind, that means when there are only 2 characters, we'll check if is an L H minus 1, we'll check if string of L and H are matching or not. So we'll return directly return string of L equal to string of H, so which is try character. If it is that, then directly we are returning 0. In this case, AA or BB, both are matching. If not, if they are not matching in A and B case, we'll return 1. So in this way, our recursive formula is generated. Our recursive algorithm or recursive pseudocode is generated. So in this way, we need to write our recursive function to find minimum insertion into a string to make that string a palindrome one. Now we can trace the code with some similar one. Let's trace it for these 2 characters, 2 strings ABA and ABC and A. Now, sorry, not ABA, it should be ABC. It should be ABC and ABCA. Now let's proceed with the algorithm. We are passing L equal to 0 and H equal to 2 over here. So we'll check whether L is greater than H, just like this condition. No, L is not greater than H. L is equal to H. No. L is equal to H minus 1. No. So it will check if string of L equal to H, then get the minimum insertion. No, string of L and string of H are not matching. So it will pass for this 2. But over here, 0 and 2 is passed. Over here, we'll pass 0, 1, A and B as an LH, and we'll pass 1 and 2 as an B and C. Now we'll check over here again. If L is greater than H, no. L equal to H, no. We'll check if L equal to H minus 1. So in 0 and 1, yes, L equal to H minus 1. So we need to return either 0 or 1 based upon this condition. So in both the cases, it will return 1. We need to return 1. So it will return 1, and that will also return 1. So that will come over here, else case of the previous recursion ABC ka previous recursion. So as we need to return minimum out of it, sorry, just a minute. In algorithm, we forgot to add +1. Minimum out of it +1. So minimum out of it will return 1, and +1, that means it will give you 2. So see, once we created the algorithm, we need to traverse it for the given cases, and then we can create a super solid algorithm. So we missed 1 over there. So now we understood that 1 + 1 will become 2. That means 2 characters are required over here. So if we see the trace, it is something like this. We have first checked for 0 length, starting 0 to 2. That means for the length 2, we have checked. Now we are checking for 0 to 1 and 1 to 2. That means two strings we have checked of length 1. Correct? Now let's see over here. If over here we are passing 0 and 3. Now A and A are matching in this condition, string of L equal to string of H. So it will directly call for just one recursion of string of L plus 1 H minus 1, which is 1 and 2. So over here we are checking for length 3 from 0 to 3, sorry, 0 to 4, 0 to 3 with length 4. And then as the characters are matching, we are directly jumping to two length from 1 to 2. And again in 1 to 2, it will return B and C. As B and C are not matching, it will go for this condition. It will return 1 over here. So minimum characters required over here will be 1 plus 1 equal to 2. That will be either, yeah, so that will be something like this: A, B, C, and A. So either we can insert B over here, which will be directly giving 1. Okay, sorry. While tracing, we just missed something. Just a minute. Yeah. So it can be something like this. B and C will go over here and it will return 1. It will return to 1 to this condition where A and A are matching. That means we'll go over here, get minimum insertion of string of L plus 1 H minus 1. Over here, we are not adding plus 1. So plus 1 won't happen. It will just add 1. So final answer will be 1. Out of it, it will return 1. So that's why it's just one character over here, which we will insert to make this string as a palindrome. So see over here, if we trace, we understood that we are going something like this. First, we were going from 0 to 3, and then we are going to 1 to 2, and then proceeded still smaller step. Now say suppose the length was 0 to 4, we would have gone to first either 0 to 3 or in this case 0 to 3, this one, and 1 to 4. So we are going for the two length from this to this in recursion. Now say suppose checking for the worst case only. In this, if they are not matching, then now in 0 to 3 again we'll go for the two steps, either 0 to 2 or 1 to 3, and in 1 to 4 again we'll go for 1 to 3 or 2 to 4 in the recursion. So over here with the length 3, over here with the length 4, over here with the length 2, sorry, over here with the length 5, over here with the length 4, over here with the length 3, and then 0 to 2 again we'll go with the 0 1, 1 2, 1 1 2, 2 3, again 1 2, 2 3, and for 2 4, 2 3 and 3 4. With the length 2 will pass this. So if you see, we are following one pattern, and again over here if you see this subroutine call, we are making unnecessary multiple times. That means this problem we can think to solve with the dynamic programming. So let's build up the strategy for dynamic programming from the recursive trace. So recursion may, we understood that we need to proceed the lengthwise. While recursive call, we were processing actually lengthwise, 0 to 4, 0 to 4 and 0 to 3, 1 to 4, and all the lengths substring we are checking whether they are palindrome or not, and if they are not palindrome, what is the minimum number of insertion we need to require to create this string as a palindrome. So once we discuss this, now in a dynamic programming, so in recursion it is top-down approach. In dynamic programming, we'll follow bottom-up approach, in which first we'll check for this kind of strings, and then we'll check for this strings, then we'll check for this strings. That means we'll first check two length strings, which is A, B, B, C, C, A, such like that. Then we'll proceed for the two length string, then we'll proceed for the three length string, and then we'll proceed for the four length string. So we need to check something like this. So we may need to write a loop something like this, which will give us 0 1 1 2 1 3, sorry, 0 1 1 2 2 3 and 3 4. So first loop, which will be something like this, which is giving us 0 1 1 2 2, 3, 3, 4, 2 length string, and then it will give us 0 to 2, 1 to 3, and 2 to 4. This long string of 3 character long, and then proceed to 4 character long or 5 character long. Now we need to store result so that this kind of extra recursive call we don't do, or multiple times we don't calculate the same result. So we need to store this result into table of L and H. These are L and H. Result belongs to length and height, such that L and H for 0, 1 will store a result, for 1, 2 will store the result, or 1, 3 will store the result, such like that. So that we need to store. So now we understood that there is a requirement of a table, now table of size 2, and for loop will be of something such that it gives us the all length string. So let's create the DP solution out of it. I hope this is clear recursive formula. The similar formula will create for the DP. So let's write function called integer get minimum insertion for the given string character string array. We are passing integer L and integer height. Now let's see what are the things required. First was integer table that we were creating to store the result for L and H. We are passing L and H as well. Over here L and H is not required because L and H we are not passing it recursively, so L and H is not required. L and H we can proceed over here in the loop. So L and H will keep it over here. We can just pass over here string of length n. Okay, and one more character is required, so I'm keeping the space over here. That character will be for this, because over here the gap is 2, then the gap is of 3, or the length is of 2, length is of 3, then length is of 4, and then length is of 5. So that is required. So we'll write one character length. For this length 2, 3, 4, and 5, we need to proceed. So for that for loop, we will write on the length. Correct? So let's start. First of all, if you are writing into C, you need to do memset, which is like it will fill up the table with all the zeros. So we'll do something like this: memset table with 0 and size of table. So that will fill all the entries of table with zeros. Now let's start the for loop. So the for loop we need to write is something like this. We need to start the length from 1, length less than or equal less than n, and length plus plus. So that means it will go for the 2 length, 3 length, 4 length, 5. Sorry, 1 length, 2 length, 3 length, 4 length, 5 length. Now if length equal to 1, we need to create a table such that L and H becomes that. So we'll write something like this for loop for L equal to 0 and H equal to length. Your H should be less than n and L plus plus H plus plus. So let's see if your length equal to 1. If your len equal to 1, you'll get 0 as equal to your L and H equal to len. Len was 1, so H equal to 1 in this case. So you'll get 0 and 1. Now in next for loop for this, your L plus plus, so L will become 1 and H also plus plus, which will become 1, which will become 2. So that means you will get for LH 1 and 2. Then L equal to plus plus, L equal to 2, H equal to 3, 2, 3, and L equal to 3 and H equal to 4. So for all these substrings, you'll create an entry into table of LH. Correct? In table of LH, you will create the entries for all 2 length characters 0, 1, 1, 2, 2, 3, and 3, 4. These are the unnecessary extra calls. So this, you will fill up the table with the entries that what is the minimum number of characters required to create this length AB or BC or CA or CD to create this two character string into a palindrome. How many minimum number of insertions are required? So that you will write. And then when your gap or length equal to 2, you'll write something like this: 0 2 2, 1 2 3, and 2 2 4, which is like this: 0 2 2, 1 2 3, and 2 2 4. So for that, again, you will fill up the entry, and finally, when you will fill the table for 0 to 4, you will have in the answer. So we'll follow the same formula. The table of LH equal to, we'll write directly with the star character so that it requires less space. String of L equal to string of H. If string of L and string of H are equal, we can directly go and check what is the table required for L plus 1, H minus 1, correct? And if these are not matching, if say suppose they are not matching, then we can fill up with, so it's a tri-character colon, then we can fill up them with the same formula: minimum of table of, just like the recursive one, table of L minus 1 H, or minimum from table of L plus 1, sorry, L plus 1 L plus 1 H. I think I have done mistake over here. It should be L H minus 1 and L H minus 1 and L plus 1 H. Minimum of that plus 1 should be returned. So with this case, it will return the answer. So if you trace, it will fill up something like this: for length equal to 1, 0 1 1 2 1 3 table entries will be filled for LH. Then for length 2, the table entries for L0 and H2, it will be filled. L0 and L3, L equal to 1 and H equal to 3, it will be filled. And such a way for 0 and 4, it will be filled. So that means once these two for loops are over, we can return the character or the table for 0 to length n minus 1. So for that, we will have the answer. So you can see over here, for 0 to n minus 1, length of 5 string, and in that n minus 1 will store the 0 to n minus 1 table of 0 to n minus 1 will store the answer. So we over here, we understood that for the given question, how to think, how to create a dynamic programming solution, and from the dynamic programming solution, how to write from the question, we understood that how to create a recursive formula and recursive solution, and from the recursive solution with such kind of traces, how to write a dynamic programming solution. I hope you enjoyed the video. Thank you.